Assalamu alaikum dear students. Today we are going to discuss the equation of hyperbola. What is the standard form of this hyperbola? You know that the hyperbola is of this type with foci f1 and f2 such that the distance between the two foci is 2c, that is OF equals to OF1 equals to OF2 equals to C, which implies that the coordinates of these two foci is F1 equals to C0 and coordinates of F2 equals to minus C0. Here this x-axis is the transverse axis of this parabola with center as O. This means that AB or the vertices of this parabola such that AB equals to A implies that OA equals to OB equals to A, which implies that the coordinates of A are this minus A0 and coordinates of B A0. Now let P of xy be any arbitrary point on this parabola, this hyperbola. And yesterday we discussed how to find this difference of distances, that is pf2 minus pf1. This equals to 2a by the definition of this hyperbola. Now here coordinates of p or xy, coordinates of f2 minus c0 and coordinates of f1 c0. So we will find the distance between pf2 and pf1 by using the distance formula. Pf2 equals to root of x plus c square plus y square. Pf1 equals to root of x minus c square plus y square by distance formula. Now substituting in this equation, Pf2 minus Pf1 equals to 2a, which implies that under root of this x plus c whole square plus y square minus under root x minus c whole square plus y square equals to 2a. On squaring and simplifying this equation, we simply get x square upon a square minus y square upon c square minus a square equals to 1. You know that a is the distance of the vertex, one of the vertex from origin. C is the distance of one of the foci from the origin. And we define another parameter, we define another constant b as b equals to root of c square minus a square, which implies that b square equals to c square minus a square. Substituting in this, x upon a square minus y upon b square equals to 1, where b square equals to c square minus a square is the required equation when p of xy lies on this hyperbola. Now conversely, let's assume that p of xy, that is any point p of xy, satisfies this equation which we obtained when p of xy lies on this hyperbola, that is x upon a square minus y upon b square equals to 1 with a less than c. From this equation, y square is equals to b square into x square minus a square upon a square. Now here p is the point with coordinates x1 y1, f1 coordinates this c0 and coordinates of f2 are minus c0. Now we will find pf2, which simply equals to a plus c upon ax using b square equals to c square minus a square and substituting y square equals to b square into x square minus a square upon a square. Similarly, pf1 equals to root of under root of x minus c whole square plus y square equals to root of x minus c whole square, substituting the value of y square, because p of xy satisfies x square upon a square plus y square upon b square equals to 1. So from this we get minus a plus ca into x. Now we will find this difference of distances, that is pf2 minus pf1. This equals to a plus ca by x minus a plus ca by c by ax. Now this simply equals to 2a. Here p is any arbitrary point, so any point on which satisfies the given first equation, that is x square upon a square minus y square upon b square equals to 1. If any point satisfies this equation, this implies that the difference of distances from two fixed points is constant. Hence, by definition, this p of xy lies on the hyperbola. So from this we conclude that x square upon a square minus y square upon b square equals to 1, when b square equals to c square minus a square and c is greater than a, is the required equation of hyperbola with transverse axes or the transverse line as x-axis, or simply when the foci lies on the x-axis. Now if we will discuss the special cases, if a equals to b, when the length of the conjugate axis equals to the uh, length of the transverse axis, then x square minus y square equals to a. So this very hyperbola is called as the equilateral hyperbola. So equilateral hyperbola is that hyperbola when a equals to b. Now when this transverse axis is along x-axis, then its equation is x square upon a square minus y square upon b square equals to 1, which implies that x square upon a square equals to 1 plus y square upon b square. Now 1 plus the positive, this means that its value is greater or equals to 1, which implies that x by a whole square is greater or equals to 1, or simply modulus of x by a is greater or equals to 1, or mod of x is greater or equals to mod of a. This means that either x is greater or equals to a, or minus x is less or equals to minus a. Minus x is less or equals to minus a. Like here in this x greater than a, this means that all those x's, the value of this x's are either greater than this or lies on along this, or they lies on this side of this x-axis. This means that this hyperbola whose the uh, transverse axis is along x-axis never touches the conjugate axis. So because x is greater than a or minus x is less than minus a, this statement means geometrically that this portion and this portion of hyperbola never touches the conjugate axis of this hyperbola. Now similarly, now if we consider the hyperbola when this transverse axis or transverse line lies on the y-axis, then its equation is of the form of y square upon a square minus x square upon b square equals to 1. Here the foci lies on the transverse axis, which implies that they lies on the y-axis. Hence their coordinates are 0 plus minus c. Vertices lies on the this y-axis, which implies that the coordinates are 0 plus minus a, where b equals to root of c square minus a square. So this means that this is a hyperbola whose transverse line is along this y-axis. Clearly in both the equations, if xy is the point which satisfies these two equations, this means that x minus y minus xy minus x minus y also lies on this, also satisfies the given two equations. So from this we conclude that this hyperbola, whose first one is whose transverse line is along x-axis, second one is whose transverse line is along y-axis, is symmetric about both the axes. Because symmetric means if xy is the point, then if minus x y is also on this means that it is symmetric about y-axis. Now if xy is the point on it such that x minus y also satisfies or also lies on the given curve, then we say that it is symmetric about x-axis. That's why we simply say that these two hyperbolas are symmetric with respect to both the axes. Here we have two equations. One, x square upon a square minus y square upon b square equals to 1 implies that its transverse line lies on the x-axis. Similarly here, y square upon a square minus x square upon b square equals to 1 is that hyperbola whose transverse line lies on y-axis. This means that the positive coefficient here, coefficient of y is positive, here y square is positive. This means that its transverse line lies on y-axis. So if we have equation of hyperbola such that the coefficient of x square is positive, this means that its transverse line is along x-axis. Now if the coefficient of y square is positive, this means that its transverse line lies on y-axis. So only sign of the x square or the y square tells us about the transverse axis, but not the denominator, which one is greater or which one is smaller, because in ellipse, if the denominator of or the quotient of this denominator of x square or the y square are greater, this means that that axis is the major axis. But here it is the only sign which tells us about the transverse axis. Like if we consider here x square upon 9 minus y square upon 16 equals to 1, this means that a is here 3, b is 4. Here quotient of x square is positive, this means that transverse line lies on x-axis. Its length is 2a, that is 6. Coordinates of foci are plus minus c0, where b equals to root of c square minus a square. Now similarly, if we consider y square upon 10 minus x square upon 5 equals to 1, here coefficient of y square is positive, this means that transverse lies on this y-axis with a square equals to 10. This means that a equals to root 10. Hence the length of transverse axis is 2a equals to root 2 root 10, which lies along y-axis. So it is the only sign which gives us the information about the which axis is the transverse axis. If x square is positive, this means that the transverse line lies on the x-axis. If y square is positive, this means that it lies on the y-axis. Now similarly, we can define the lattice rectum of hyperbola, whose equation is x square upon a square minus y square upon b square is 1, or y square upon a square minus x square upon b square equals to 1. Its length of lattice rectum is 2b square upon a. Now it is that line which passes through the forks, one of the forks, say for example f1 and f2, perpendicular to the transverse axis with endpoints lies on hyperbola, this parabola. Like if we consider here this line segment, its endpoints lies on this hyperbola. It is perpendicular to this transverse axis passing through forks. This means that this is lattice rectum. Similarly, from this side, this is the lattice rectum. So inshallah, in tomorrow's video lecture we will discuss few problems on how to find the hyperbola, how to find the equation of hyperbola when constants are given. So thank you.